Defining functions. So definition. A relation is a set of order pairs. Example 1. Determine which of the following order pairs are a relation. So if you see here in A, all of them are ordered pairs. Therefore, in A is a relation. And in order pair, the first component is x coordinate and second component is a y coordinate if we are talking in a sense of the Cartesian system. So B we see is an ordered pair, therefore, and B is a relation. C is the same relation because it's ordered pair. And D, we already see here, is a relation because it's an ordered pair. So let's go to the next slide. Functions defined by order pair. Definition. A function is a relation for which each value from the set, the first component, it means x, of the order pair is associated with exactly one value from the set of a second component, let's say this is a y, of the order pair. So determine which of the following order pairs are functions. If we are looking in the A here, A is a minus 2 and 5. Minus 2 and 5, minus 1, 0, 2 and minus 3. So this is a function because each first component is associated with a second component, exactly one of the second component. And if we are going now in a B, and of course this is a relation too because the function is a relation. So I just want to mention this, is important. And a B is minus 1, 0, 0 minus 3, 2 minus 3, 3 minus 0, and minus 1 and 2. But as we see here, the first component is associated with the two values, is with the 0 and 2. This is not a function. This is just a relation. So B is not a function. C is a function because the first component is associated exactly with one of the second component of the order pair. So C is a function. D is not a function because minus 2 here associated with 3, minus 2 is associated with minus 6. Therefore, D is not a function. Let's go to the next slide. Functions defined by diagram. So determine whether each relation in diagram defines a function. The set A, set B. Set A, every component has to be associated exactly with one value in the set B. So as we see here, A is associated with P, B is with one element, C is with one element. So none of the set elements of set A is associated with two elements. Therefore, A is a function. B is not a function because A here is associated in the set A, the element, the first component here, is associated with the two elements in the set B, is with the Q and R. So B is not a function. C is a function because each element of the set A is associated exactly with one value of the set B. And D is a function because every element is associated with one element in B. And this is, we would call the function 1 to 1. Okay. Now let's see functions defined by tables. We have x and y, minus 1 and minus 1 here. X is the first component is associated with two components with the second components of the set or the set. You see here minus 1 with the 2 and minus 1 with the minus 3. So this is not a function, the table 1. The second table here, every element of x is associated with one element of y. Therefore, this table, second table here is a function. Functions defined in real world situation. Here are a few examples. 4. Determine if each of the following relation is a function. Justify your response. Input is a student, so x is a student or the first component, and second component or y is the output, is the scores on the last quiz. Because x is everyone is a different student, a different name, everyone is unique, and in a second, even though it's repeated, it doesn't matter, but in the first one should not repeat any element twice. Therefore, every student is unique. A is a function. But if we take in a score, and the last quiz of the last quiz is an input, or is a x, and the output, or is a y, or a second component, is a students. Here, some scores can be repeated because some of the students have the same score. For example, 90 have two students, and here 90 as the x is repeated, has two different values. Therefore, B is not a function. C, student and cell phones. Students are, all of them are different, none of them is the same. All the students are different, unique. And cell phone numbers, all of them are different. It could be like a function 1 to 1. So if we have a height of the students, and the students, some students can have the same height. For example, 5'8" can be two students, or 6 feet, two students can be the same height. So here in the input, x value is going to repeat to have the two students, two values. Therefore, the D, because one element can be associated with two students, so this is not a function. And function defined by equation, determine if each of the following is a function. But before I go there, just let me take a pen here. Okay, now I'm going to the next slide. If we are looking here in A, and in the next slide, I have A is this graph of the function. So this graph, but this graph of A is a function because if I'm drawing the vertical line, it's going to hit just in one point. Anywhere, if I'm drawing a vertical line test, if I'm taking, is going to pass because the graph of the function is going to hit in one point, is going to have intersection with the vertical line test. So this is a function. Let's go in B. B is y squared equal with 25 minus x squared. So this is, B is a circle. But if I'm taking the vertical line test, you see here there are 2 points. It's going to hit 2 points. This is not a function because it cannot pass the vertical line test. To pass the vertical line test, it has to everywhere the graph of the function to intersect just in one place of the vertical line test. So now if we are going with the C, is y squared is equal to x squared minus 25. So C is this one. This one is not function either because just if you take one, any line if you take here, but just in one line, if it cannot pass, that is not a function. So this is enough just in one line to not pass it, and this is not a function because cannot pass the vertical line test. Let's go to the next question. D is y squared equal with kx. K can be any integer. So this is a D. So it cannot pass the vertical line test. This is not a function because cannot pass the vertical line test. So this is not a function. So let's go to the E. E is y equal with 3 in exponent x. So this is exponential function. It can pass because everywhere when we draw a vertical line, is going to adjust in one place the graph, so it can pass the vertical line test. So this is a function. So this is yes. This is a yes, is a function. So here is a no, and this is no. Those are not function.